Hi dear friends, welcome to TechAcad. In this video we are going to discuss CCNA version 7 packet tracer activity, configure IPv4 and IPv6 static and default routes. Before coming to this activity, friends, if you like to get CCNA version 7 online classes or any project support, you can contact our team using our website. Link you will get from the description below. And also, if you like to get this type of technical videos in future, consider subscribing and don't forget to enable that bell icon near to the subscribe button so that you will get notification message whenever we upload a new video. Coming back to our activity, here we can see our addressing table with the devices, interfaces, and here they given IPv4 as well as IPv6 address with its prefix. Coming to the objectives, in this packet tracer summary activity, we will configure static, default, and floating static routes for both the IPv4 and IPv6 protocols. Configure IPv4 static and floating static default routes. Configure IPv6 static and floating static default routes. Then configure IPv4 static and floating static routes to internal LANs. Configure IPv6 static and floating static routes to the internal LANs. Then configure IPv4 host routes. Also configure IPv6 host routes. These are the objectives of this packet tracer activity. Also, we will go through this scenario. In this activity, we will configure IPv4 and IPv6 default static and floating static routes. Also, they given a note. The static routing approach that is used in this lab is used to assess your ability to configure different types of static routes only. This approach may not reflect networking best practices. Yes, it's really mean that. So coming to the instructions, part 1, configure IPv4 static and floating static default routes. The packet tracer network requires static routes to provide internet access to the internal LAN users through the ISPs. In addition, the ISP routers require static routes to reach the internal LANs. In this part of the activity, we will configure an IPv4 static default route and a floating default route to add redundancy to the network. We will go ahead. Step 1. Configure an IPv4 static default route. On Edge router, configure a directly connected IPv4 default static route. This primary default route should be through router ISP1. Coming to our topology, here we can see our Edge router, and we are going to configure this directly connected IPv4 default static route towards this ISP1. And here we have to specify its exit interface. So here we can see its exit interface to this ISP. It's a serial 0/0/0. Even we can configure this IPv4 default static route using its next hop address. That is, we have to specify the IP address of this interface serial 0/0/0 in this ISP1. Let me see that IP address ISP1. When we can use this address 10.10.10.1. Okay, fine. I will go to this Edge router and we will do the configuration. Enable conf t, and here we will give IP route, then 0.0.0.0. Then we have to specify the sum to mask 0.0.0.0. Then we will give your exit interface. It's a serial 0/0/0, right? Or as I told, even we can asset with this next hop address serial 0/0/0. Now coming to step 2, configure an IPv4 floating static default route. On Edge router, configure a directly connected IPv4 floating static default route. This default route should be through a router ISP2. It should have an administrative distance of 5. So we have to set this administrative distance of 5, so it becomes this floating static default route. And here we can see we are going to configure on edge router through this ISP2. Here again they specifically mentioned to configure a directly connected IPv4 default static route, right? Yeah, we will use this exit interface which is connecting to this ISP2. We can verify it. The interface is serial 0/0/1. Okay, we will configure this default a floating static default router using this exit interface. So again we will go to this edge router. Again we can give this command IP route 0.0.0.0. Then it's exit interface. I will verify once more. Serial 0/0/1. Serial 0/0/1. Then here we can specify its a distance metric for this route. So here we can see they specified to give this administrative distance of 5. We will give that here. Then press enter. We will go to part 2. Configure IPv6 static and floating static default routes. In this part of the activity, we will configure IPv6 static default and floating static default routes for IPv6. First of all, we will configure an IPv6 static default route. On edge router, configure a next hop static default route. See, here they specifically mentioned we have to use next hop address. The primary default route should be through router ISP1. As they specified, we are going to use this next hop address. So we have to get the IPv6 address of this interface, that is a serial 000 in this ISP1. So just we will go to our addressing table, ISP1, and here we can see its IPv6 address. So we will copy this address because we have to use this address as next hop address. That's fine. Next we will go to this router, that is edge router, and we will do that. We have the command IPv6 route :/0. Then we have to specify its next hop address. I will put a question mark and we will see what is next. Here we can see IPv6 address of next hop. We already copied that. Then press enter. Step 2. Configure an IPv6 floating static default route. On edge router, configure a next hop IPv6 floating static default route. The route should be via router ISP2. Also use an administrative distance of 5. So here we can see we have to configure this IPv6 static default route, and we are going to configure with its administrative distance through this ISP2. And here we will configure using its next hop IPv6 address. Hence we have to get the IPv6 address of this interface, that is a serial 001 in ISP2. We'll go to addressing table, ISP2 serial 001. Here we can see its IPv6 address. We'll copy that. Okay. Again we will go to this router and we will set that IPv6 route :/0, and here is its IPv6 next hop address. Then we have to set its administrative distance. It's 5. Coming to part 3, configure IPv4 static and floating static routes to the internal LANs. In this part of the lab, we will configure static and floating static routes from the ISP routers to the internal LANs. Step 1. Configure IPv4 static routes to the internal LANs. On ISP1, configure a next hop IPv4 static route to the LAN 1 network through edge router. Now coming to the topology, here we can see 2 internal LANs. such as LAN 1 and LAN 2, and here they given its network address LAN 1 192.168.10.16/28 and LAN 2 192.168.11.32/27. Here these two networks, I mean these two remote networks, it's unknown to this ISP1. Hence we are going to configure this static IPv4 static routes in this ISP1. And here they specifically mentioned use a next hop IPv4. That means to this LAN 1 and LAN 2, I mean to reach to this LAN 1 and LAN 2, we have to use this next hop IP address, I mean the IP address of this interface, serial 000 in this edge router. We will go to our addressing table, and here we can see the IP address of this interface, serial 000 in this edge router. Here we can see that 10.10.10.2. Just I will copy this address. Then we will go to ISP1. Okay, I will keep this here. Enable conft IP route. Then we will specify the network address 192.168.10.16. And prefix given is /28. Space, I will put a question mark here, and you can see we have to give a destination prefix mask 255.255.255. It's 28 means 240. Also we have to specify its next hop address. We already copied that IP address 10.10.10.2. Also we will configure this LAN 2 network also. IP route 192.168.11.32, and it's submit to mask prefix given /27. It's a 224. And again here also we have to use the same next hop address to reach to this LAN 2 10.10.10.2. Step 2. Configure IPv4 floating static routes to the internal LANs. On ISP1, configure a directly connected floating static route to LAN 1 through the ISP2 router. Use an administrative distance of 5. Then on ISP1, configure a directly connected floating static route to LAN 2 through the ISP2 router. Use an administrative distance of 5. We will configure this IPv4 floating static routes to this internal LANs LAN 1 and LAN 2, and it's through ISP2. So what will be the next hop address? And here let me see. Yeah, they clearly mentioned configure a directly connected floating static routes. So we have to use its exit interface, right? And here we can see exit interface which is connecting to this ISP2 G0/0. We will do the configuration. Coming to ISP1 again, we will configure IP route. I think we can copy the same command we given here. That's fine. Just I will copy from here, because instead of this next hop address we have to use its exit interface through ISP2. So it's a G0/0. Here we will give a G0/0. Also we have to specify its administrative distance of 5. I'll mention that here, 5. Also we can copy this line. This is to LAN 2 using exit interface, that is G0/0 with the AD5. Coming to part 4, configure IPv6 static and floating static routes to the internal LANs. Step 1. Configure IPv6 static routes to the internal LANs. On ISP1, configure a next hop IPv6 static route to the LAN 1 network through edge router. Also, on ISP1, configure a next hop IPv6 static route to the LAN 2 network through edge router. We have to configure using its next hop IPv6 address. We can see to reach this LAN 1 and LAN 2, we have to go through this next hop, that is serial 000. We have to get the IPv6 address of this interface, serial 000 in this edge router. Serial, here we can see, just I will copy this address. Yes. Now we will go to this ISP1. Here we will give IPv6 route, and here we can see the network address for this LAN 1 2001 colon db8 colon 1 colon 10 double colon /64. Correct. Here we can see that. Now we have to give its next hop address. Already copied it. I will show in single line. Here we can see that. Okay, that's fine. Now again, here we can see our LAN 2. We will configure this IPv6 route. It's 2001 colon db8 colon 1 colon 11 double colon /64, right? And we have to give its next hop address. We already copied it. Then press enter. Step 2. Configure IPv6 floating static routes to the internal LANs. On ISP1, configure a next hop IPv6 floating static route to LAN 1 through the ISP2 router. Use an administrative distance of 5. Okay. Then on ISP1, configure a next hop IPv6 floating static route to LAN 2 through the ISP2 router. Use an administrative distance of 5. If your configuration has been completed correctly, you should be able to ping the web server from the host on LAN 1 and LAN 2. In addition, if the primary route link is down, connectivity between the LAN host and the web server should still exist. Okay, we will configure this IPv6 floating static routes to this LAN 1 and LAN 2, and it's through this ISP2. So here we have to use its next hop address as this IPv6 address of this interface, so that is G0/0. Okay, I will get the IPv6 address of this interface G0/0 in this ISP2. Here we can see the interface G0/0, and here we can see its IPv6 address. Just will copy that. Then we will come back. Okay, that's fine. So we'll go to ISP1. Okay, here already we given these commands. Here we have to change only this next to hop address, right? So already I copied it. Just I will paste here. Then I will copy this command. Okay. Then in the beginning we will paste it with a space. So here we can see only changes this next to hop address. Then we have to specify its administrative distance, right? It's 5. Okay, that's fine. Next we will copy this second line here. This is for LAN 2. Copy and paste here. Then we have to give its it's IPv4. I have to copy IPv6. It's here, right? Okay. Then we have to give its next to hop address. You can copy and paste here. Also we have to give its administrative distance, that is 5. Now we will go to part 5, configure host routes. Users on the corporate network frequently access a server that is owned by an important customer. In this part of the activity, we will configure static host routes to the server. One route will be a floating static route to support the redundant ISP connections. Step 1. Configure IPv4 host routes. On Edge router, configure an IPv4 directly connected host route to the customer server. So coming to topology, here we can see our customer server, and we are going to configure host routes from this Edge router. Okay. Then on Edge router, configure an IPv4 directly connected floating host route to the customer server. Use an administrative distance of 5. We will configure that, and here we can see customer server address 198.0.0.10, and we have to configure it in this Edge router through this ISP1, and we have to use its exit interface. It's a serial 0/0/0. So coming to this Edge router again, enable conf t, and here we will give IP route. Then we have to give its IP address, this customer server IP address, not the network address, 198.0.0.10. Okay. Then we have to give this destination prefix mask 255.255.255.255. Okay. Then exit interface, it's a serial 0/0/0. That's fine. And now we will configure this host routes through this ISP2. So to reach this customer server, exit interface will be serial 0/0/1. Here we can see that, which goes to ISP2, right? Okay, we will do that. Here I will copy this command, because we have to change this interface, exit interface, that is serial 0/0/1. Also we have to give its administrative distance of 5. Here we can see the command in single line. Coming to step 2, configure IPv6 host routes. On Edge router, configure an IPv6 next hop host route to the customer server through the ISP1 router. So here we have to use a next hop address. That means the IPv6 address of this interface, serial 0/0/0 in this ISP1. And here we can see our customer server IPv6 address. We have to configure with this. And I will get the IPv6 address of that interface, serial 0/0/0 in ISP1. Here we can see that. Sorry, it's IPv6 address. So I will copy this, right? Serial 0/0/0. It's correct. Then we will go to this router, and here we have to give its IPv6 address. We can give IPv6 route. It's 2001 colon db8 colon f colon f, then double colon 10, and we have to give prefix 128. Then we will give its next hop address. Already we copied it. Okay. And finally we will configure this IPv6 directly connected floating host route. Here we can see the exit interface, the IP address of this interface, serial 0/0/1 in this ISP2. ISP2 serial 0/0/1, it's here, right? So before that, just I will copy this command. It's same. We have to change only this next hop address, and also we have to add administrative distance of 5. Now we will get its IP address, IPv6 address, ISP serial 0/0/1. We can copy this IPv6 address and paste here. Then give its administrative distance of 5. Then press enter. Perfect. So we configured everything. We can verify the configuration. We can go to this router, edge router, give exit, show IP route. We can go to the route and we can verify it. Here you can see static route. Also we can give a show IPv6 route. Here we can see IPv6 static route we configured. Now we can go to this ISP1, enable show IP route, and here we can see the route we configured statically. Also we can give a show IPv6 route. It's here. Even we can test the connectivity. We will ping from PCA to customer using IPv4 as well as IPv6. We'll go to PC-A, then I will go to command prompt. Let me try to ping to customer server. Ping 198.0.0.10, and let me try the connectivity. I will give fast forward, and we can see we get the replies. Once more I will try it. It's working, right? Even we can ping to customer server IPv6 address 2001 colon db8 colon f double colon 10, and we can see it's working. Perfect. Okay, right. So friends, in this video we learned how to configure IPv4 and IPv6 static and default routes, and here we can see its completion status. It's 100%. Now dear friends, if you have any doubt, any suggestions regarding this packet tracer activity, please comment below, or you can reach our technical team using our website. Link you will get from the description. And also, if you like our video, if you like our channel, give a thumb and share with all your friends. Stay tuned, and we will meet again with the next video. Thank you.